Hello everyone, I am Dr. Saurabh Saxena, working as Assistant Professor in Department of Applied Science and Humanities, ABES Engineering College, Ghaziabad. So, topic for today's discussion is Liuville's extension of Dirichlet's integral. Dirichlet's integral we have already covered in the previous video, and today we are going through the extension of the same. So here we go with the statement. In Liuville's Dirichlet's extension, the function that was used in Dirichlet's integral, x to the power L minus 1, y to the power m minus 1, z to the power n minus 1, that remains same. Only the multiplication with the function of x plus y plus z is taken extra. So if the function is in this form, strictly in this form, x to the power L minus 1, y to the power m minus 1, z to the power n minus 1, multiplied by f of x plus y plus z. If this function is integrated over the volume that is bounded by the coordinate planes and the plane x plus y plus z equals to h1 and x plus y plus z equals to h2. Mathematically, the conditions may be given as x greater than equals to 0, y greater than equals to 0, z greater than equals to 0, and x plus y plus z is less than equals to h2 and greater than equals to h1. So if in this region such a function is evaluated, then Dirichlet's integrals Liuville's extension may be taken into the consideration, and according to that, the value of this integral will be gamma L, gamma m, gamma n divided by gamma L plus m plus n integral h1 to h2 fu into u to the power L plus m plus n minus 1 du. So there is nothing very special points that to be focused on. Only the thing is the function should be in this form, and the region at which the function is to be integrated should be in this form. For that region, x should be positive, y should be positive, z should be positive, and x plus y plus z should be greater than equals to h1 and less than equals to h2. So further we'll illustrate the same theorem or same extension by an example. This is the question now. Evaluate triple integral log of fx plus y plus z dx dy dz, the integral extending over all positive and zero values of x, y, z, subject to condition x plus y plus z is less than 1. So let us consider the integral as triple integral log of x plus y plus z dx, dy, dz over the region V. Now, for what is the region? It is defined for, here it is written, the integral extending over all positive and zero values. So what does it mean, positive and zero values? Means here x is positive, greater than equals to 0, y is greater than equals to 0, z is greater than equals to 0. And condition, the last condition is x plus y plus z is less than 1. X plus y plus z, the value of this expression is given to be less than 1. And by these three conditions, x greater than 0, y greater than 0, z greater than 0, we can directly write like x plus y plus z is less than equals to 0, is greater than equals to 0. So now the condition is in the same structure that is required for Liuville's extension. X greater than 0, y greater than 0, z greater than 0, and x plus y plus z is greater than equals to 0 and less than equals to 1. So if we match with the conditions, this 0, it may be considered as h1 and this 1 may be considered as h2. So the given integral may be written as I is equals to triple integral over P x to the power 1 minus 1, y to the power 1 minus 1, z to the power 1 minus 1, dx, dy, dz. And now by Liuville's extension, the value of I may be written as gamma L. So L is x to the power L minus 1. So L, value of L is 1, value of M is 1, value of N is 1. So gamma L, gamma M, gamma N divided by gamma L plus M plus N integral h1 to h2. The limit in the last statement we notice the limit of the integral is h1 and h2. So what is h1? h1 is 0 and h2 is 1. Fu, whatever the function that was given in the left hand side, here it was missing. The function was also given here. Log of x plus y plus z dx dy dz. This function was given in the question itself. Log of x plus y plus z. So gamma 1 divided by gamma 1 plus 1 plus 1. Limit h1 to h2. Fu, the function is logarithmic. So I'll be writing log and x plus y plus z. This entire function will be replaced by a single variable u into u raised to the power L plus M plus N minus 1 du. So it becomes I is equals to gamma 1 upon gamma 3 integral 0 to 1 log u into u square du. Now we can integrate this. Log gamma 1 is 1, gamma 3 is factorial 2, it is 1 by 2 integral. Now we integrate this function. First function, integration of second. So u square integration is u cube by 3 minus whole integration of differentiation of first into integration of second. The limit will be 0 to 1 and here limit will be 0 to 1. It is equals to 1 by 2. Now, when you will put the upper limit 1, log of 1 is 0, and when you will put the lower limit 0, so u cube, just because of u cube, the value 0 will be put, and means the first bracket will give you the answer as 0 minus 0, corresponding to the upper and lower limit, minus integral u and u, you will be getting u square by 3, 0 to 1 du. May be written as 1 by 2, minus 1 by 3 may be taken outside, minus 1 by 3 integral 0 to 1 u square du. It is minus 1 by 6 u cube by 3. Limit 0 to 1. It will be minus 1 by 18, 1 minus 0. And the answer becomes minus 1 by 18. So this is the application of Liouville's extension, how it may be used in case of the function x to the power L minus 1, y to the power M minus 1, z to the power N minus 1 is multiplied by the function of x plus y plus z. These are the references. So thank you very much.